Welcome viewers. In this video we'll see the details about transmission parameters, ABCD parameters coming under two-port network. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, two-port network under ABCD parameter, transmission parameters. The transmission parameter or ABCD parameters are widely used in transmission line theory and cascade networks. So in the two-port network there are so many parameters available, admittance, impedance, like that. These transmission line parameters are used, transmission parameter used in transmission line theory and cascade network. So in describing the transmission parameter, the input variables V1 and I1 at the port 1 dash, usually called the sending end, are expressed in terms of output variable V2 and I2 at the port 2 dash, called the receiving end. So we know that two-port network we have input port and output port. Input port, the variables V1 and I1, that is because of transmission line it is called a sending end parameters. That is expressed in terms of output port 2 dash, V2 and I2 is normally called a receiving end. So the sending end parameters V1, I1 expressed in terms of V2, I2. Right, now we'll see the further detail. The transmission parameter provide the direct relationship between input and output. So the main advantage of these parameters are we can see the relation between input and output. Transmission parameter are also called a general circuit parameters or chain parameters. Is also called a general circuit parameter or chain parameter. Now we'll see the equation. It's defined as V1, I1. So V1 and I1s are given in terms of V2 and I2. In that ABCD parameters are available. V1 equal to A V2 minus B I2. I1 equal to C V2 minus D I2. So this A, B, C, D as the parameters. We'll see the definition of this A, B, C, D later. So this is the general equation. The negative sign used in I2 is and not for the parameter B and D. Right. So this I2, the negative sign is used with I2 and not for this parameter B and D. Right. So this I2 refers the current, not for B and D parameter. This negative refers current direction. So that is given. So both the port current I1 and minus I2. So we are taking I1 as positive, I2 as negative, or directed to the right. That is negative sign in the equation 1 and 2. The current at the port 2 dash which leaves the port designated as positive. So that leaves the port, so that this I2 is termed as minus, negative. The port 2 it is leaving, so that we are taking the I2 current as negative. Now we'll go for the matrix format. How we can write this matrix format? So the A, B, C, D are called transmission parameters. In a matrix form, this equation 1 and 2 can be written as, so this we have V1 and I1. This side we have V2 and I2 minus I2. Then A, B, C, D. So this A, B, C, D is nothing but a transmission matrix. Right. So the equation now it is written in matrix format. So this is the input parameter V1, I1. This output parameter V2, I2. I2 expressed as negative. A, B, C, D as a transmission matrix. Transmission matrix. Now we'll see the what is the definition of this A, B, C, D parameter. So for a given network, this parameter can be determined as follows. So we can frame the two-port network. So input port 1 dash, I1 V1 voltage and current. Output port 2 dash, V2 I2 voltage and current going towards. With the port 2 is open, that is I2 is 0. In order to find the parameters, we are making the output port 2 dash is 0 2 diodes is open. If it is open means the current I2 is 0. By applying voltage V1 at the port 1, equation 1 we have. So we already have equation 1 and 2. It is given in a network format, input port and output port. To determine ABCD parameter, we are making output port 2 dash is open. That means I2 is 0. Now we can substitute I2 equal to 0 in equation 1 and 2, so that we are able to find the ABCD parameters. Now we'll see the equation 1 and 2. So this is equation 1 and 2. So what we are doing, output port 2 dash is open. So I2 is 0. This I2 is 0. So in equation 1, I2 is 0. So this term is 0. Only we have V1 equal to A into V2. So that A equal to V1 by V2. Bring this V2 in the denominator. So A equal to V1 by V2. Similarly, in second equation, the current I2 is 0. So the totally this term is 0. We have I1 equal to C into V2. Bring this V2 in the denominator so that I1 by V2 is C. The parameter C is I1 by V2. So by making output port open condition, the current I2 is 0. By substituting I2 is 0, we can able to find the parameter A and C. A is nothing but V1 by V2. C is nothing but I1 by V2. Now we'll see the what is these parameters. Right. So we calculated A equal to V1 by V2 by making I2 is 0. Output port is open circuited. And C equal to I1 by V2 by making I2 equal to 0. So we can write this A equal to V1 by V2 as 1 by A, reciprocal, taking reciprocal on both the side. 1 by A equal to V2 by V1, I2 equal to 0. That can be written as G21 I2 equal to 0. So what is 1 by A? 1 by A is called open circuit voltage gain. Output voltage by input voltage. So that it is called a voltage gain. So that we are taking reciprocal 1 by A. Right. So we calculated the term from the parameter A. By taking 1 by A, we are able to find the voltage gain. Similarly, C equal to I1 by V2. 1 by C, taking reciprocal on both sides, 1 by C equal to V2 by I1. By making I2 equal to 0, that is nothing but Z21. Impedance parameter, the separate video available for impedance parameter. Z21 is nothing but V2 by I1. That is called open circuit transfer impedance. Transfer, that is V2 in the output port, I2 in the input port. So that is called a transfer impedance. Already we have open circuited. The 2 dash is open circuited, so it is called a open circuit transfer impedance. So from the parameter A, by taking 1 by A, we can able to find voltage gain. From the parameter C, by taking 1 by C, we are able to find the open circuit transfer impedance. Now we'll go for the remaining two parameters. So now the port 2 dash is short circuited. Earlier open circuited, now short circuited. While short circuit, the current will flow, but the voltage is 0. V2 is 0. Now we can substitute this V1, this V2 equal to 0 at the, so by V2 0, applying the voltage V1 at the port 1 dash. So from the equation 1 and 2, we can able to find. So in the second case, 2 dash is short circuited, so that V2 equal to 0. We can apply V1. We are able to find the remaining two parameters. Now we will see what is the equation 1 and 2. So this equation 1 and 2. What we are doing, output port is short circuited, V2 equal to 0. Now V2 is 0. So V2 equal to 0 means the entire term is 0. So what we have, V1 equal to minus B into I2. Bring this I2 in the denominator so that minus B equal to V1 by I2. Similarly here, this V2 is 0, so the entire term is 0. What we have, I1 equal to minus D into I2. Bring this I2 in the denominator. So that minus D equal to I1 by I2. Right? So in the earlier case, we make I2 equal to 0. The second case, we are making V2 equal to 0. Now we'll see the further the further explanation. Right, now what we calculated, minus B equal to V1 by I2 by making V2 equal to 0. Output port is short circuited. Minus D equal to I1 by I2 by making V2 equal to 0. So this minus B can be written as minus 1 by B. We are taking reciprocal on both the sides. I2 by V1. So this I2 by V1 is nothing but Y21 admittance. It is coming under admittance. Short circuit transfer admittance, because we already short circuited the second output port, so that is short circuit transfer. What is transfer? It is current in the output port, voltage in the input port, so that it is a transfer. V by I is impedance, I by V is admittance. So short circuit transfer admittance. In previous case we calculated open circuit transfer impedance. Now short circuit transfer admittance is calculated. Similarly, minus D can be written as minus 1 by D, reciprocal on both the sides. That is I2 by I1. Here I1 by I2, I2 by I1. So that is nothing but alpha 2-1. Nothing but a current gain. Output current by input current. So that which give the short circuit current gain. So from this ABCD parameter, first we are making output port is open circuited, so that I2 equal to 0. From that we are able to find A and C. By making 1 by A and 1 by C, we are able to find voltage gain and open circuit transfer impedance. The second case, the output port 2 is short circuited, so V2 equal to 0. From there we are able to find B and D, minus B and minus D. From minus 1 by B and minus 1 by D, we are able to find short circuit transfer admittance and short circuit current gain. So finally what we have, voltage gain is calculated, current gain is calculated, transfer impedance and transfer admittance are calculated. So that will be very helpful for analyzing the transmission line. So that it is called a transmission parameters, ABCD parameters. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.